So today, what are we on? One Wednesday. Yesterday it was that Intech current model 790. Today we're going back to 1981. It's a Mustang CB1000, which uses the Cybernet PTBM002F, their economy chassis, which always works very well for me. And I was surprised how well that radio worked yesterday, with it being a current model. It's not often we see real RF meters on modern sets. Or deviation, it actually goes to 2.2. So if I could find something like a file or something like a fiberglass brush, then we may well be able to start by cleaning this filthy fuse holder. And we better put in a fuse. So at least the radios come with a power lead, and they're quite few and far between. So unlike the Amstrad, where you end up with the 901 being either the Japanese one, the Hong Kong one, or the fake Hong Kong one, these are always the Japanese chassis, and they always work nicely. What a funny fuse holder. Do you know what? It's broken, isn't it? I'm there faffing about. The fuse holder's actually broken, so we'll have to fit a new one to that. In the meantime, we'll run it into our power supply without. If I'd got one on the bench, I could have dealt with that, but I haven't. So, power supply set to 2 amps maximum. There we go. So we just need to plug our instrument speaker in. And switch on. So it needs the meter lamp doing. And it needs some screws in it, because it hasn't got any. It's had some nasty soldering around there. We'll go over that with isopropyl alcohol. Oh dear, it's the ballast resistor's gone. 9 times out of 10 I find once that's happened, the PA's gone. Right, let's see whether it still transmits. Well, you know what, surprisingly it does. Switch picture in picture on. He's doing 3.1 watts with no ballast resistor. The last thing you want to do on sets like this is to destroy the output transistor, which is very expensive. And this is the wrong output transistor. So if you look on eBay, you'll see plenty of people selling 2SC2166s, but they're fake. Mitsubishi stopped making these about 20 years ago, so it's not possible to have a nice, shiny, brand new looking transistor on a photo on eBay, because any which have been installed for 20 years will be tarnished, won't they? You know, it doesn't take a degree in brains to work that one out, and unfortunately we've bought fake ones, and they haven't been fake prices. You know, if you're expecting the output transistors to be 39 pence, well, something's wrong, isn't it? Because you're going to expect them to be a couple of pounds. But you know, when you start paying £7.50 and they're still fake, it's not on. So we won't be changing that as long as on the spectrum analyzer we haven't got any silliness. So we'll just put that on and we'll see. So the first thing we will do on this radio, I'll switch this to low power so we're not thrashing the transmitter. And what we will do, we'll just set up the VCO, because it is important on this chassis. And I usually have to dig my service manual out with having a memory like a sieve. Let's have a look. Here we are. Amstrad 901. We could use the Fidelity 2001 manual, but we may as well use the Amstrad one. So I just need to recap what they're doing. Channel 40. And we're looking for between capacitor 9 and ground, we're looking for 4.5 volts. Floating chassis, so need to put that negative lead, or put that onto the power supply negative. Just put that so it's in the picture. Capacitor 9. It's the far sided pin, not near me, far towards the back of the radio, and we need to be in transmit. It should be 4.5, it's 3 point whatever. So we just need to pop that up a bit. To be honest, we're doing this topsy-turvy. We start on channel 1. So we start off in receive, I'm telling you all wrong, and it's transformer 1 to get 2 volts. Well, that's as near as damn it, to be honest, but just for the video, we'll adjust T1. Near as damn it. So then we go into transmit, and we should also have 2 volts, and that's 1.99. Let's see what I mean. I'm being silly here because I won't be able to get it even as close as that. Well, I've got 2 volts, so it's the trimmer capacitor just there. So we'll now go back into receive, and then we select channel 40, which I should have gone 1 down, and they want it to be around 4 to 5 volts. Well, it's in lock, and it's in lock on transmit, so I've satisfied that set. But it is an important adjustment, because on this chassis you can easily end up with channel dropping out at the extreme ends of the radio when you're in a particular temperature. So that's that done. we'll just go back to full power. I'll just put into the spectrum analyzer 27.79125 and put channel 20 on the CB set and key up, and you can see straight away if I select that on the camera, there's our 27 megs, and nearly as big. What have we got? We've got our second harmonic. So it's 56 megs. So we know the radio is doing 3 watts, 3.1. So let's put it on our Zetagi meter, because I bet it'll read the 4 watts of 27 megs, 3 watts of 27 megs, and I bet it reads the other 3 watts, which is on 50 something megs. There we are, look at that. Off scale, it's doing more than 10 watts. So, you know, the screwdriver expert, look, I'm doing 10 watts. Wow, aren't we impressive? No, you're doing 3.1. The rest of it is on another frequency. So, we will change the ballast resistor for a new one, because it's missing. Okay, so we've now got a ballast resistor in there. Well, we've now got lower on our spurious, and we now have 2.6 watts. So we'll see whether we can tune it up. I know perfectly well the customer's not going to want to pay for a new output transistor. It's just going to have to be what it does. Maximum. 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 We may have had the coil stretcher in this radio as well. It's interesting. Maximum. Oh, look at that. To do 4.6 watts with a ballast resistor in. So now, we go back to the spectrum analyzer, and that's before I started with the coils that can get tweaked around. If you remember when we started, that's a huge, that's off the screen there, and we've got a smaller one there. So at least we've got less output going on to 54 megs. So just look at these coils, which don't look like they should be like this. Ow! burns finger on resistor. In Practical Wireless there was a cartoon strip called RF Burns, and that was supposed to be the bloke's name. Now we've dropped that significantly again. So I'll just see whether I can get an actual reading. So marker. Minus 62 dBm, so we're just in spec. I'm interested now that it's doing 4 watts to see what the Zetagi meter says it's doing. The Zetagi meter says it's doing 5.1. That's better than 10 Zetagi watts, isn't it? Right. So that's straightened up the rather screwed up transmitter. So we'll see what the deviation is. We were doing CPT yesterday. Just have to retune the test set. Wallow, 4.5. That's no good. That gives you less range, not more range. It's not like AM. So we'll try it at there and see whether that works with the whistle test. Wallow. That's exactly right. 2.2. So that's deviation sorted. So let's see how on frequency it is. And some of these are getting the state where they won't quite go on frequency, but I've only ever had to change 2 crystals in 38 years. So let's see what happens. That's not far out. 2779125 it should be. It's within spec, so we'll just pop that up a bit. There we are, spot on. Good. So on the RF meter, we know the radio is doing 4 watts, and I've forgotten about the red TX light inside the meter. That needs to just pop down a little bit. It should be in the centre of the red zone. It's that one, isn't it? There we are, centre of the red zone it is. And although this can't be calibrated, we'll just check the low power. Should be 0.4 watt, but it's just how it is. And on this particular set, it's 100 milliwatts, which is actually the lowest one on the manual that's permissible. It really doesn't matter. Nobody's going to bother about that at all. Right, that brings us onto the receiver. Just put some service hole switch cleaner into that volume control, which is noisy. So what we're going to do, we'll put an S9 signal on, and we'll look at that on the oscilloscope. It's a bit dim, why is that? It doesn't like that, does it? In fact, it does sound awful as well. So the detector is that one there. Yeah, it's just a dodgy lock point. I bet this set sounded garbled. I think we've got peak there. So, having done the detector, it's doing 0.3 microvolts for 12 decibel sinus. We'll just go through the tuning. We'll switch to the sinus meter. Absolutely spot on, no adjustment at all. So just for the record, the 12 dB sinad is now doing 2.27 microvolts for 12 decibel sinad, and it's doing 0.24 for 10 decibel sinad. I'll tell you what, incredibly, it's doing 0.65 for 20 dB sinad. It's a very nice receiver there. Let's see if we can set the S meter up. So I've got 100 microvolts, so that should be S9, and it's just over the S9, so it just needs to pop down a fraction. I think it's this one. Yep. You know what? We can't get plus 30 with like this. I'll just key up my handheld right next to the radio. We're going to have to set this meter not quite true. I'll set it between 9 and plus 30 just as a compromise. Or he'll moan it's got a lazy needle. That leaves us with the squelch to do. So set the squelch to full, switch the signal generator on, and I want the radio to start opening up when we have 100 microvolt S9 signal. So we're at 10 microvolts, 30 microvolts. I don't want it in at that, so we need to adjust the squelch preset. so it's off. Now we'll adjust the signal generator. Nope. Too sensitive. It's one of these, is it? There we have it, 100 microvolts. So now we'll turn the squelch right down, switch the signal generator off, and set the threshold. Switch the signal generator back on, and see when it comes in and goes out. And it's coming in at 0.85 of a microvolt. It's going in at going out at 0.39. So that sensitivity is fine. Well, you know what? I reckon we've done that. Good. There's no sign of any distressed capacitors. Right, to conclude then, I've just done the meter lamp on this, and done the fuse holder, which is somewhere down there. Done the fuse holder, new one. So as far as new parts go, done the ballast resistor, brought the power up. If you remember, it was 3.1 watts without a ballast resistor, but doing 10 watts on the Zetagi meter, and then retuning the set, putting a ballast resistor in, brought it up to a full 4 watts with a ballast resistor, and it's now reading 5.5 on the Zetagi meter, meaning that we've lost all those watts which were on other frequencies, which is great. Well, it was switched on, but it isn't now. So it should be on an aerial now. Let's have a flick round. We'll better plug the speaker back in. Oh, as far as the meter lamp goes, I've had to glue gun it on the side of the meter because the front, the screws, have rusted in place. I had a go and I couldn't even get one out, and it's so, the plastic is so weak. Don't want to damage the front because it's a lovely looking front, so I thought it was safer, rather than to start drilling screws out and all that kind of stuff, we'll just do it like that. And let's plug the speaker in, there we go. 1/9, Roger.
To Lincoln, we'll sort you out. Be worth coming. A clap day.
Well, unusually, there was somebody on. Right, there'll be a on-the-air test in due course. That won't be today. And I think tomorrow we've got an audio line full recap. So we did the Uniden one, didn't we? And it's an audio line this time. So thank you for watching the Mustang CB1000 from 1981, and it's working very nicely.